This presentation was made possible by the collaboration of Javier Batista, Luc Bouy, Mike Gazdaika, and Gil Henkel. We will be presenting to you the significance of wall thickness. In metal injection molding, production is more convenient for components that are smaller than about 12.5 centimeters in size, and have geometries favorable for this type of manufacturing. The definition of wall thickness is pretty self-explanatory. Parts have different dimensional thicknesses throughout their structure that contribute to their unique geometry. In the diagram below, figure 2, you can see an example of this. The thickness for wall B is greater than the thickness for wall A, having a ratio of 1.4 in difference. Wall thickness is a determining factor for the production of a design because it affects cooling time, the binding time, and heating and cooling ratios. These aspects of PIM are of significant importance because thermal stresses are generated when these are set into action. If the heat transfer properties related to wall thickness are not taken into consideration, serious problems such as early debinding or cracking of the component may occur. In the diagram below, you can see an example of how an engineer might go about in making design considerations for wall thickness proportions in a component. Wall thickness values are typically about 3 millimeters, but many times they can have thicknesses as small as a decimal of a millimeter and as large as 2.5 centimeters, depending on the design of the component being made. Aside from the thickness value, thickness variations should be small within the components. In PIM, variations typically have a ratio within 2.3. To the bottom left, you can see a graph illustrating this, and to the bottom right, you can see how design selections are made based on distribution and wall thickness values. Optimizing wall thickness to fit these standards give the manufacturer higher yield, short cooling and heating cycles, a reduction in cost, and the potential to increase the component size. As mentioned before, components rarely exceed 12.5 centimeters, illustrated in the bottom right graph, but through wall thickness optimization, exceptions such as these tweezers and scissors can be made. In conclusion, part geometry is important in PIM. Wall thicknesses may vary within an individual part, but it should be done to a minimum and gradually. Overall, it is preferable to have wall thicknesses from 1 decimal of a millimeter to 3 millimeters. And last, wall thicknesses should be considered when performing the binding and furnace cycles.